Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Expressions and equations make 1/3 of the test questions. Analyze and solve linear systems of equations. Please pause the video and read the description of this standard.
Hello and welcome. Here is what you need to know before we get to the examples.
Before watching this video, it's highly recommended to watch the previous video, Solving Linear Equations of One Variable. Here's the link to it. The Golden Rule.
Okay, consider the system pair of equations y equals ax plus b and y equals cx plus d, where a, b, c, and d are numbers. Now, if a is different than c, the system will have one solution. If a is equal to c, then you have two options. First, the system will look like this. Now, obviously, if these two are the same, so you have the same line, which means you will have an infinite number of solutions. So if b is equal to d, then the system has infinitely many solutions. Now, if b is different than d, then the equation has, or the system has no solutions.
Rationale for the Golden Rule.
So why is this going to work? Consider the system of equations y equals 5x minus 2 and y equals 2x plus 1. So the first line here, I'm calling it line 1, and I'm calling it line 2. So you see line 1, the slope is 5, and the y-intercept is -2. For line number 2, the slope is 2, and the y-intercept is +1. So that you have different slopes, so the line will intersect in one point. So this is my first line, this is my second line, the slopes are different, then they must intersect somewhere, and that's where they intersect in this situation. So the system has one solution, which is the intersection of the two lines. They want you to know that the intersection of the two lines.
Rationale for the Golden Rule.
Now the second case here, now I have the same slope. So both lines are parallel. Now since the y-intercepts are different, then those lines are parallel and they do not intersect. So, which means the system has no solutions.
Rationale for the Golden Rule.
The third case is when both the slope and the y-intercept are the same, then the two lines are overlapping, and in this case you will have an infinite number of solutions.
How to solve a system, pair of linear equations in two variables.
Here are the tools available to us to solve a system of linear equations. First, you need to simplify each side of each equation. So you'll have 4 sides. You need to simplify them first. You may need to use distributive property and combine like terms. Then you can solve the system by graphing method, by substitution, by elimination, and all of these will be covered shortly. It depends upon the system. Sometimes one of those is better to use than the others. It really depends upon the system. So let's see some examples here. Now we need to solve the linear system of equations. This one here. Obviously, because of these two are different, I know they have only one solution. So in this case, I'm going to use substitution. So I'm taking the value of y from this equation and plug it into this equation. So I put this is equal to this. Now, there's nothing to simplify on each side of the equation, so I just need to make sure the variable is on one side and the number is on the other side. So I'm going to need to move this from here to here, subtract 2x, gone. Now you have 3x minus 2 is equal to 1. Now I need the variable by itself, so I have to move this to the other side, add 2, so you get 3x equals to 3. Now you divide by 3, because I need one whole, I need only one, so x is equal to 1. Once you have a value, x is equal to 1, you can use any one of these two equations to find the other one. So here I am going to use the first one, so I put 1 here instead of x. 5 times 1 minus 2, y is equal to 3. Now, it's good practice sometimes, most of the time, is to check your answers. So the answer is 1, 3. Okay. Now you can check this answer by plugging these values 1 and 3 in these equations and see if they are satisfied. And you see here 3 is equal to 5 times 1 minus 2. The other one, 2 times 1 plus 1 is 3, which is good. Example number 2. Now, when you look at this example, you see that it's inviting you to do elimination, see, because these two are the same. So, but first, let's do a substitution. If I want to do a substitution, then I have to find the value of one y or x from one equation and substitute it into the second equation. So I'm calling this as E1, this is E2. Now calculate y from E1. All I have to do is I have to move this term to the other side. So here's the equation, add 2x. So y is equal to 2x plus 7. I'm calling this equation number 3. Now, if I take this value and now substitute it in the second equation, 3 times y, 2x plus 7, plus 2x is equal to 9. Now I have to do the distributive property. I get 6x plus 21 plus 2x. Now combine terms. 8x plus 21 is equal to 9. Subtract 21. 8x is equal to negative 12. Divide by 8. So x is equal to negative 1.5. Now you can use any one of the equations here to find y. The easiest one is to use this here, equation number 3. So y equals 2 times x. X is negative 1.5 plus 7. Y is equal to 4. So that's the solution. Now, as I started this question, I noticed that these two are opposite signs. So it's easier than doing this is to do, this is the answer. You can always check your answer. And now if I take the same example now, but since I'm going to do it using now elimination, it's easier for this example. By elimination, that's E1, that's E2, add them. Why add them? Because adding them cancels the 2x. You will get an equation with y only. So 4y is equal to 16. Divide by 4, y is equal to 4. Now you can use any one of these equations to find x. So if I substitute in E1, 4y minus 2x is equal to 7. Subtract 4. Minus 2x is equal to 3. Divide by minus 2. X is equal to negative 1.5. So you see that easier in this situation to use elimination than substitution. Okay, now we come to more examples. Now this one is example that was on Ohio State Test 2022, question number 12. This is level 2. A system of equation is shown. That's the system. What is the solution to the system? So obviously it has one solution because these two are different. Now in this situation, the easiest way to do is substitution. So equate this with this. So before that, here we're doing graphing. Okay, let's see. We're doing graphic. That's fine. We can do graphic first. So this first line, the y-intercept is 2 and the slope is 5. So if you go from here, 5, 1, 2, 3, 4, 5, 1, 5 over 1. The second one, the y-intercept is 1, so it starts from here. And again, the slope is 6, which is 6 over 1. Let's go from here, 1, 2, 3, 4, 5, 6. So you see how they are intersecting in this point. So that's your solution 1, 7. So this requires really precise drawing so you can figure out where the intersection is. It's probably easier for this example is to use substitution, and that's what we're going to be doing again here. We're going to use substitution. So I equate these two together, subtract 5x. 2 is equal to x plus 1. Subtract 1. X is equal to 1. Now, you can substitute in the first equation or the second equation. It doesn't matter. When x is 1, you put x1 here. Obviously, you find y to be equals to 7. So you see this one here, we do graphing and we do substitution. Example number 5. This is really a simple example. That's in 2021. First question. That's a level 1 example. So you have two lines here and they're asking you what is the solution of the system of equations shown in this graph. So this again, the solution is the intersection, which is this point here. So that's x is 2, y is negative 4. Now, they want you to put the 2 here and negative 4 here. Don't make a mistake because you will lose points. So this is, see how easy this question? Question number 6. This one is a level 3 question. It's very interesting. Lines A and B form a system of linear equations. Each line contains 2 of the points shown. Move a pair of coordinates to each blank box to complete the statements so that the system of equations has one solution. Okay, so I need to put those pairs here so that A contains the coordinate this and B contains the coordinate this, so that A and B are intersecting. So the first thing to do, I would say, is to draw these points. This one, negative 2, 6, is right here. Negative 2, 5. 5, 6. 5, 5. So these are the 4 points. Now, if you make a line here and a line here, those lines are parallel and they will not intersect. There will be no solution. So that doesn't work. If I do a line like this and a line like this, again, these are parallel lines and they will not intersect. So now the only option left for me is to do like that. So now if A is the line going like this and B the line going like this, then you will have a one solution. They will intersect and the system will have a one solution. Example number 7. We're going to do that in 2 ways. A system of equations shown. What is the solution to the system? So first I'm going to use a graphing method. So the first one here, okay, the y-intercept is negative 7. So it starts from here. And that slope is 2. Rise 2 over 1. And then you draw the line. The second one, it starts from 5. That's the y-intercept is 5 right here. The slope is negative, so it's going to go this way. It's going to go this way. So negative 1 over 1. So you're starting from 5. 1 over 1 is here, and you draw that, and you get the other line. Now you look at the intersection is this point right here. It's 4, 1. I intersection 4, 1. So your answer would be 4, 1. Now that requires, some precision in terms of drawing the lines. Now we can same question using a substitution. So I'm going to take this y from here and put it here. Now I need to move this x to here. So I add x here. 3x minus 7 is equal to 5. I have to move this here to the other side. 3x equals 12. Divide by 3. X is equal to 4. Once you get x, you can use any one of these equations to find y. So if I do x here, negative 4 plus 1, it gives me 1. Or in the first equation, 2 times 4 is 8. Excuse me, minus 7 is 1. It's 4, 1. Example number 8. A system of equations is shown. What is the solution to the system? See, when you see something like that, and that's in that in years 2018, question number 35. So when you see like something like that, don't try to use graphing because you might not get it right. Look, these they cancel when you add them together. That's called elimination. Elimination. So put them together and add them. Add the two equations. This is gone. 3x equals 6. Divide by 3. X is equal to 2. Once you find x, and you can use any one of these equations to find y, as obviously I can use this one is easier. So 2 for x plus y is 7. So what's the number if I add it to 2? I get 7 is 5. So you get the answer in order. X is 2, y is 5. Don't swipe this, you would lose points on the test. And you can always check your answer. Example number 9. This is a really simple example. The graph of a system of two linear equations is shown. Which point represent the solutions to the system? They really want you to know that the intersection of the two lines is the solution, which is point R. That's it. Example number 10, and this is a practice test, question number 15, and it will be followed by similar ones, 3, 4 of them. We will do all of them so that you understand how it's done. So Karishma and Joshua collect shells on the beach. The given equations model the number of shells K that Karishma has and the number of shells J that Joshua has. So you have a system here and they want you how many shells does Joshua have. So I need to find the value of J. Okay, in this situation is really straightforward. You take this value from here and plug it here. It's called substitution. So take J from equation 2 in equation 1. K, J is K minus 30, like terms. Add 30. 2K is 84, divide by 2. K is 42. Okay, K is 42. Use the second equation here to find J. 42 minus 30. J is 12. That is the answer to this equation, to this problem. You can always check your answer. Something similar here. Pedro and Gisela collect marbles at a hobby shop. The given equations model the number of marbles P that Pedro has and the number of marbles G that Gisela has. Okay, you have this system here. How many marbles does Pedro have? P. Again, you take P from here, plug it here. Substitution. Now, combine, subtract, Divide by 2. G is 37. If G is 37, add 8 to it, we get 45. And that's your answer to the question. A similar one, Eric and Jimmy collect football cards. The given equations model the number of football cards, E, that Eric has and the number of football cards, J, that Jimmy has. How many football cards does Jimmy have? So I need to find J. Again, take J from here, put it here. Combine term, subtract 11, divide by 4. E is 14, but he's asking not E, he's asking J. Substitute in equation number 2, 3 times 14 plus 11. P is 53. And you can always check your answer. See, 53 plus 14 is 67. Example number 13. This is a practice test level 2. It's similar to the other ones. So here are the two equations that we are going to be solving. So again, we get D here, plug it here, combine, subtract, add, divide by 2. A is 32. 32 minus 19 is 13. Okay, that's it. Example number 14. This is a OST 2016 question number 11. Now here a system of equation is shown. What is the value of x in the solution to this system? So he's giving you y and asking you to find x. The best thing to do here is to take this 9 and put it here. Okay, 2x minus 9 equals 15. Add 9. X is equal to 12. That's the answer. They are asking you what is the value of x. Now, obviously, if you want to draw this line here and this line, you can find that, but this is a lot easier, straightforward. Example number 15, similar example. You have to take the y from here and put it here. That's in 2016. So the thing that students might get confused about is the negative here. So negative times negative is positive. So you get plus 3. Now, again, you subtract 3. Divide by 4. X is equal to 1/2. And that's what they are asking you to find. Number 16, very similar now, but a little bit more complicated here. So y is 7, so you have to put 7 here. 7 here. So you get 8x minus 3 times 7, 21. And from here, solving one equation in one variable, add 21. 8x is equal to 40. Divide by 8. X is equal to 5. Okay. 5 times 8 is 40 minus 21 is 19. Very similar, different numbers here. So you take the y9 and put it here. Now add 9 to both sides. Minus 2x is equal to negative 8. Divide by negative 2. X is equal to 4. 18, very similar. Now I made this example for you. Now he is giving you x, or I'm giving you x. I want you to find y. So again, you substitute x here. You get 24, because 12 times 2 minus y is equal to 15. Subtract 24. Minus y is equal to minus 9. Y is equal to 9. Similar, x is given, we need to find y. X is 5, 5 times 8 is 40. Subtract 40, minus 3y is equal to minus 21, divide by minus 3, y is equal to 7. This last equation, problem is a little bit, I don't expect that the state will ask you something like that. This is more like an algebra one, but I figured I can give you it just to show you something a little bit different. But it's really not that complicated. This is a system of two equations. Now, I'm going to use an elimination process. So I can eliminate x or y from the two equations. Here, I'm going to multiply this by 2, and I'm going to multiply this by 3. Why? Because 2 times 3 is 6. 3 times 2 is 6. Then I get equations where I can eliminate x. See? When you multiply by 2, that means every term has to be multiplied by 2. 6x, 4y equals 2, minus 6x plus 9y plus 24. Now I have the same equivalent system, but now you can see if I add them together, this is gone. I will have equation in y only. Add them, you get 13y is equal to 26, divide by 13, y is equal to 2. Now you can use any one of these equations to find x. So I used E1 here. So 3x, y is replaced by 2, 4 is equal to 1 minus 4. 3x is equal to minus 3, divide by 3, x is equal to negative 1. So the answer is negative 1 and 2. X is negative 1 and y is 2. Okay.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.